Hi guys, today we're going to talk about lesson 5 in unit 2, which is solving inequalities. These are the inequalities that you guys learned in elementary and middle school: greater than, less than or equal to, or greater than or equal to. When we represent these inequalities on the number line, we represent a greater than by an open circle and an arrow to the right to represent greater numbers. Less than, we represent less than with an open circle and an arrow to represent smaller numbers to the left of the circle. When we represent less than or equal to, we represent the number by a filled circle and an arrow to the left to represent smaller numbers. And then when we represent greater than or equal to, we graph a filled circle and then an arrow to the right for the greater numbers. So let's take a look at how we can represent solution sets of inequalities on the number line. The first example, we have x greater or equal to 5. So to represent this solution set, I'm going to put 5 in the middle of the number line. I have x is greater or equal to 5. That means that the solution set includes the 5. I'm going to represent that 5 by a full circle. And then I'm including every single number greater than 5. That means I'm going to represent these numbers by an arrow to the right of the 5. The second example, I have x less than or equal to -3. Again, I'm going to put -3 in the middle right here. And then I know that in this inequality, I'm including -3. That's why I'm going to have a closed circle. And then I'm including every single number less than -3. That means I need an arrow to the left here to represent these numbers. Our next example is x less than -20. I'm going to have -20 in the middle of the number line. I'm not including -20. It doesn't say less than or equal to. That means I need to represent -20 with an open circle and then an arrow to the left to represent the smaller numbers. Next example is x greater than 1/2. I'm going to put 1/2 in the middle. 1/2 is not in the solution set. That's why I need to represent that number by an open circle. I'm including every single number greater than 1/2, which means I'm going to have an arrow to the right. When we solve inequalities, we solve inequalities in the same way we solve equations, using the properties of real numbers, which are the distributive property, the associative property, and the commutative properties. All these properties can help us justify the steps that we need to take to solve the inequality. We use the properties of inequalities instead of the properties of equalities to solve inequalities, and you'll see these properties in a second. Along the previous properties, we have the additive property of inequality, which we use when we add or subtract the same quantity from both sides of the inequality. This property is similar to the additive property of equalities that we talked about in lesson 2.2. The second property that we need to know is the multiplicative property of inequality, and we use this property when we multiply or divide the same quantity from both sides of the equation. Again, this property is similar to the multiplicative property of equalities. The only difference between them is that for the multiplicative property of inequality. Every time, every single time we have to multiply or divide by a negative number, we have to flip the inequality to make a true statement. Every time we need to multiply or divide by a negative number on both sides of the inequality, we need to flip the sign of the inequality to make a true statement. And when you see, I'm going to give you examples and you'll see exactly what we need to do in this case. So let's take a look at some examples. Our first example here is x plus 5 is greater than 14. And we said that solving inequalities is almost the same as solving equations, which means in this case, to be able to solve this inequality, I need to take away 5 from both sides. And I took away 5 from both sides using the additive property of inequality. This leads to x is greater than 9. And this is the final solution, which include every single number greater than 9. So in this case, we don't have just one exact value for x. We have many values, and we're going to represent these values on the number line. 9 is not included in this solution set, which means I'm going to have to make an open circle for 9, but I'm including every single number greater than 9, which is to the right of the 9 on the number line. And that represents the solution set for this inequality. Example number 2, we have negative 3x less than 24. And to solve this inequality, we need to divide both sides of the inequality by negative 3 using the multiplicative property of inequality. The only thing that we said is going to be different in this case is that since we're dividing by a negative number, we have to switch the inequality sign for the solution, which makes me end with x greater than negative 8. And to represent the solution set on the number line, I'm going to put negative 8 in the middle of the number line. Again, the solution is not just one number. It's many values that can satisfy this inequality and make it a true statement. I'm not including negative 8, that's why I'm going to have an open circle here for negative 8, but I'm including every single number greater than negative 8 on the number line. That's why I'm going to represent the greater numbers with an arrow to the right of negative 8 on the number line. Let's talk about one more example. We have 4 times x plus 2 less than or equal to 4. Again, if you want to think about solving this inequality the same way we solve equations, that means the first step we need to do is to use the distributive property to distribute 4 into x and 2. That means I'm going to end up with 4x plus 8 less than or equal to 4. This is a two-step inequality. I can use the additive property of inequality to take away 8 from both sides, which makes me end with 4x less than or equal to negative 4. This is a one-step equation. I can use the multiplicative property of inequality to divide both sides by 4 and have x by itself or isolate x by itself, which makes me end with x less than or equal to negative 1. Again, since I divided by a positive number, I did not have to switch the inequality sign at the end. So, to represent this inequality on the number line or to represent the solution set on the number line, all I need to do is to put negative 1 here in the middle. I am including negative 1 because I have a less than or equal to, which means I'm going to have a filled circle. and then I'm including every single number less than -1, which means I'm going to include all the numbers to the left of the -1 on the number line. And that's the solution set for this inequality. So this is the bottom line. We use the properties of inequalities to solve inequalities, and we use the properties of equations to solve equations. The only difference between these properties is that when we multiply or divide the inequality by a negative number, we need to flip the sign of the inequality. The other thing is that when we solve equations, we can end up with one solution or two solutions at the most, while when we solve inequalities, we may end up with multiple, infinite, or no solutions.